Hello everyone. Today I'm just going to quickly talk about the Firebolt DM2 differential assembly. It's pretty straightforward, but there are a few little tricks I've done with this differential to really improve its performance and longevity. First and foremost, let's take a look at the differential rings. I went ahead and I sanded the differential rings to make sure that they're perfectly flat. Took, I think, 600 grit sandpaper, and on a glass surface, I just simply moved the differential ring in circles. This just removes any high spots that the differential ring might have developed while it was being punched out from the sheet of metal. But overall, the differential ring was quite flat as it was. So you can if you want, you don't have to, but it's worth trying. And that's pretty much it. So I applied a thin layer of grease. Let me just turn this around. I applied a thin layer of grease in between the two halves here, which makes contact with the outdrive. And I also applied a thin layer of grease on this surface here. I did this for both sides. The differential balls, I applied just a small bit of differential grease in each hole. If you're wondering what differential grease I used the Team Associated silicone grease with the red logo on it. And that's pretty much it for the differential halves and the differential balls. Now, the thrust assembly here, pretty straightforward. I used Tamiya AW grease for the thrust section here. Now, what I did do was I decided to go ahead and have the thrust bearing outer portions here facing the opposite direction from the manual. So the actual grooves that the thrust cage would fall into, I've actually have the grooves facing outward. So what this will do is this will give you a nice smooth contact surface for the thrust bearing cage to make contact with. The grooves, from what I've read over some of the RC Tech forums, they said that the grooves tend to wear out a little bit faster than normal, and you don't get that continual smooth thrust bearing differential action. And so using the flat sides of the thrust bearing halves increases the overall performance, and the differential is a lot smoother. So that's what I've done. So that's pretty much it. Nothing too crazy, but that should definitely improve the overall performance of your differential. All right, so that's basically it. I hope that was of help. And one other quick tip, I put some AW grease on this side of the thrust cage, so when I place it into the differential half, it will stick and adhere, so when I do flip it over, make any adjustments or changes, or take out the part from this side, or disassemble a differential, this won't fall out all over the place and you'll lose your part. So it'll stay there relatively well. Okay, there you have it. Bye-bye.